this mathematical dictionary by James and James, he gives me the definition of a CUSP. Okay, the definition, it's a double point at which two tangents to the curve are coincident. So this is the function raised to the 2/3 is a cube. It's a cube root of x minus 1 squared. So when x is 1, okay, it goes to 0. So this becomes 1, 0 is the point at which they are coincident. Let's find the slope to see if it curves to the left or to the right. So the slope of this function is going to be 2/3 of this quantity, subtract 1, makes it look like this. That looks like this. The 2 is in the numerator, the 3 is in the denominator, and if I move this, it becomes the cube root of x minus 1. Okay? Let's find the slope at 1 over here is not defined. Okay? What happens when the slope is at 2? Okay? Is it up and to the right? Well, if I put 2 into the derivative over here, this becomes positive, okay? If I look at it over here, the top is positive. If this is 2, that's positive. So 2 positives, the slope is up and to the right. Let's go to 0 over here. Hopefully the slopes will be negative, okay? So I'll go back in here. If I put a 0 in here, this is the cube root of -1, which is negative. So it's be positive over negative, which makes the slopes are negative going this way. Let's have a look at the second derivative. The second derivative is going to tell me if it's concave up or down, okay? So let's go to 2 first of all, okay? So this is the second derivative. The top is always negative, okay, so it's -2. Okay, and if I put a 2 in here, this is positive. So the denominator is positive. So this is negative, so it'll be concave down. At 0, okay, if I put 0 in here, this becomes -1. It's to the 4th, so it's positive. Negative over positive makes it concave down. So it looks like this information satisfies the curve.